In this segment, we're looking at January 2020 Csec paper 2, and we're at number 6. All right, so question 6 reads, the radius of each circle in the rectangle WXYZ shown below is 7 centimeters. The circles fit exactly into the rectangle. So we're seeing that we have a number of circles that fitted beside each other and they fit exactly in that rectangle. We're told that the radius for each is 7, and we're seeing right here where we're seeing that radius right there, that's 7. All right, let's look at the question. The first question says, show that the area of the rectangle is 2,352 square centimeters. So let us say that we continue using the radius 7, and we're going to go all the way across all those circles like what I have here. All right, we would have noticed that the diameter for each circle, this would have been 7 again, and this is 7, then here is another 7. From here to here, we have 7, we have 7. So we're seeing all of these radii coming together, 7, which would have made for a circle 14 going across for the diameter. And we would have had, so we have 14 here attached to 14 there, attached to 14 there, attached to 14. So we would have had that distance there as in 14 4 times, right? 14 4 times, that's about 56 in terms of this distance is 56 centimeter going across, fully across, going like that. That's 56, right? So we could look at it as saying we have 7 8 times, and 7 8 is 56, right? Or we could look at it as the diameter and realize that we have 4 circles. So the 14 times the 4 will give us 56 for that length, or we could say the 7 times the 8 and we'll still get that 56. So whichever means we want, we'll get 56. Which means coming down, all right, it's the same circle. So we would have had 14 here, or 14 there, and 14 there. So we would have had 14 times 3 this time, which is about 42. So this then coming here, we're talking about 14 times 3, and that's 42 cm, right? So we're looking at 42 for the length, 42 by 56, or 56 by 42. So improving right now the area of this rectangle, I'll say area of a rectangle is always length times width. So that accounts for area. And in this case, we're talking about 56 times 42. So this is all I need to multiply, 56 times 42, and definitely we would have gotten 2,352 centimeters squared. All right, so hence we would have proven this here, all right? All right, so that said, we would have collected those 2 marks. And let's move on. Calculate the area of the shaded region. All right, so the area of the shaded region is the area of the rectangle minus the area of all of these circles. And we have 12 circles going on here, all right? So let's go about, so we have already found the area of the rectangle, which is 2,352, but we knew that because we already proved it. So let's find the area of the 12 circles, but we start off by finding the area of one of those circles first. All right, so finding the area of just one circle. Finding the area of one circle with a radius of 7. Remember though, the area of a circle is pi r squared. Pi is given as 22 over 7. Look, pi is given as 22 over 7, so we're talking about 22 over 7 times r, which is 7 squared. So pi r squared. So we put this together, we'll definitely get 154. So this gives us 154 centimeters squared. So that's the area for one circle. However, we have 12 of those circles. So 12 circles. So talking about the area of 12 circles, it's simply be 12 times 154. All right. So we're going to have this times 12, and that's about 1,800 and say 48 centimeters squared, right? So for the 12 circles, we would have had that. So this is the number. This is the number that we need to go in combination with the area of the rectangle. All right. So all we have to do right now is to say, all right, the shaded area, the shaded region is equal to, by principle, we're referring to the area of the rectangle minus the area of the 12 circles, which is 2,352 minus 1,848. So we subtract that, and there goes our answer. So our answer is, the shaded region is 504. Seems correct. So that is the shaded region right there. All right. Now let's look at this other question. It says the diagram below, not drawn to scale. Not drawn to scale shows a triangle MNP in which angle MPN is equal to the angle PMN, which is 52, and MN is 12.5 centimeters. So you're looking at this, right? So this diagram here is what we're dealing with. State the type of triangle shown above. All right. The moment I'm seeing these two angles being equal here and this angle right here, I'm seeing an isosceles triangle. All right, so definitely for one mark, I'll just write that this is a isosceles triangle. All right, so the moment these two angles are equal, it is telling me that this side is equal to that side. So definitely I could write 12.5 centimeters here as well, because these two sides are equal since these angles here are the same. So those are just extra information. I normally label them as I go forward. Determine the angle, the value of the angle PNM, which is this angle right here. If I'm going to find that angle there, it's only 3 angles in a triangle, and I know 2. All right, so the third angle can be found by doing this. So we're talking about the angle PNM. This is going to equal to 180 degrees, subtract the sum of 52 plus 52. So that's how I'm going to find that third angle, 180 degrees minus 52 plus 52. And then this would have left me with 104 minus 104. And this is going to leave me with 76 degrees. So this angle here is 76 degrees right there. All right, so we have a 76 degrees. So you could see that this is 76 degrees right there. All right, so having known that, they're saying to us now, calculate the area of the triangle. All right, so this is 52, this is 52, this is 76. This is 12.5, which means this is 12.5 because it was an isosceles triangle. Now, I know everything in this corner. I have this, I have that. There is a formula that we could use with sine that will help us to find the area of the triangle when we have an angle between two known sides. So for example, this principle is this. If this is, say, side A, this is side B, and let us say I have an angle at C here, the area of this triangle, so the area of the triangle is going to equal to half AB sine C. So I will be embarking on this idea to solve this problem. So the fact that I knew this angle and then these two sides, I'm able to find the area of the triangle using this formula. So we're going to go about that right now. So what we have here is to say the area of triangle, this is M and P, is equal to a half times 12.5 times 12.5. And then this will be multiplied by the sine of the angle between them, which is 76 degrees. And this will take us straight to our answer. So we're talking about a half times 12.5 times 12.5 times the sine of the angle, 76 degrees. And we would have landed a total of 75.8. And this is cm squared. Of the triangle is 75.8 square cm. Thank you for watching. Please like, subscribe, and drop a comment on the math concept. See you next time for the next video.